Today we're going to be talking about simplifying radical expressions. As we start a new chapter, notice we are on chapter 10. Simplify radical expressions using the product property of square roots. So the product property of square roots says that we can split up a square root into a times b and deal with each of them individually. So the square root of 100 can be written as square root of 4 times 25, which can be written as the square root of 4 times the square root of 25. So we can go ahead and separate them as we see fit. So what are we going to be doing here? We're going to birthday cake our numbers. Any pairs come out, singles stay in. You got a friend, you can go outside and play. If you don't, you stay inside and play on the Xbox or watch Netflix. Variables you cut in half. Any even ones, leave none inside. Odd ones will always have one left inside. So even exponents have none. Odds will always have one left in. So let me show you how this works. So here we have simplify the square root of 52. Now again, I did upside down birthday cake. It's easier for me to do on the computer. So 2 goes into 52, gives me 26. And then 2 goes into 26, 13. Again, they're all even, so I got 13. Nothing goes into 13 except for 1, and I get my candle here. So I have a pair of 2s. That's a pair. They have friends. They can go outside and play. The 13 doesn't have any friends right now, so he's going on Xbox or just watching Netflix. So those are the two 2s. They're going to go together, and they're going to come outside. The 13 stays inside and just chills with Netflix or, TikTok or whatever else you want to do. So you have 2 square roots of 13. So what about the square root of 45? Well, 45 is 5 times 9. So 45 has a 5 at the end, so we divide it by 5 and get 9. 9 can be divided by 3 and get 3. 3 divided by 1, and we finally get our birthday cake. So we have 3, 3, and a 5. Pair of 3s, those come out. The 5 stays in. It doesn't have a friend to do anything with right now, so it just stays inside the house. So the 3 and the 5 stays in. All right, what about 54? Well, 54 is even, so I divide it by 2 and I get 27. 27 is a 3 with a 9 and a 3 and a 3 and a 3 and a 1. All right, so I got a bunch of 3s and a 2 here. So these two 3s go out and do something. So I'm going to need a 3 on the outside. And notice I have a 3 and a 2 left over. Well, when those 2 are left over, they could just get multiplied together, give me 6. We don't want to write 3 times a 2. We'll make it simpler by just multiplying them. All right, what if I have a 2 and a 24? Well, let's start with a 24. Is 2 divided by 2 is 12, divided by 2 is 6, divided by 2 is 3, 3 divided by is 1. So I got a bunch of 2s and a 3, but I also have this extra 2 in front. So these 2 go together, and this 2 with that 2 goes together. So I got 2 pairs of 2s. Well, 2 pairs of 2s, well, see how I have 3 there and then this 1. So there they are in the square root of 3. These 2s and this 2 go together, and we get 2 squared, or 2 2s, which will give me 4. The 3 had no pairs, so it stays inside. If we have things on the outside, we have to multiply them together. So 2 times 2, which gave me 4. All right, here we had a 5 and a 35. So 35 is divided by 5 and gives me 7, 7 and 1. And 5, of course, is just 5. So I got a pair of 5s. Those are going to come out in front. And the 7 is going to stay inside. All right, what happens if we have variables? So we're going to do our prime factorization or our birthday cake. So 5 goes in and we get 9, 3, and 3. We did a 45 already. All right, so that's a 3 that comes out because it's a pair of 3s, and the 5 stays in. Now let's look at the variables. Remember what I said about the variables? We cut them in half. A to the 4th is just a squared. B to the 5th cut in half is 2.5, 2.5, right? So 2 comes in, but this is an odd number, so we have 1 that stays in. So 2 come out, 1 stays in. The C to the 6, cut that in half, is 3. Ignore these lines here. They do this on a couple of these problems, and they'll probably have some on your answer sheet, but don't worry about those. Now that we have all these, all the outsides go together, and all the insides go together. So the 3a squared b squared c cubed, all out in front. Again, drop these right now. We'll worry about those in Algebra 2. It's not important right now. And 5b is just 5b. All right, here we have 32. Well, what's 32? 2 and 16, 2 and 8, 2 and 4, 2 and 2, and then we get our cake with 1. So I got a bunch of 2s. So here's a pair of 2s, there's a pair of 2s. So I have 2 2s. This other 2 has no one, so it goes in. M squared becomes m to the first with nothing inside because it's even. N cubed, cut that in half, is 1.5, right? 1.5. So 1 comes out, 1 stays in. This is c to the first. I really can't cut that in half. It stays in. So then put that all together. 2 times 2, of course, is 4, mn, and then 2nc. So c right there. And we can even have ones like this with numbers in front. And notice what we did with the numbers. The 24 and the 6 still birthday caked. And the 3 and the 4, those just stayed on the outside here. These here come from my pairs. Well, let's look at the pairs. I got a pair of 2s. I got another pair of 2s and a pair of 3s. Everything pairs up. It is possible that we have that. And that's a perfect square, and that's great. So now I'm just multiplying 3 times 4 times 2 times 2 times 3, which ends up giving me 144. So notice how there's no square root here. That can happen. Most of the ones will have a square root, but this one, of course, doesn't. And that's what I have for you today.